Hello everyone. In this video, we'll be talking about finite geometric series. There's two types of geometric series we can have. First, we'll do a review of geometric series just to make sure everybody's on the same page, and then I'll talk about the two different types. So what is a geometric series? Series means we are summing up the terms in a specific type of list. And geometric, if a list is geometric or a series is geometric, that means the terms go up by a common multiple. So in this case, this is an example of a geometric series I've written out. The terms are going up by multiples of 2, right? So, or by common ratio of 2. Every time to get to the next term, we multiply by 2. So that's a geometric series. If you want to review on geometric series and sequences, go ahead and watch the previous videos I've made on this. Okay, so now we're going to talk about two formulas, actually rather just one formula, two different variations of the same formula, which we can use to find the sum of the first n terms in a geometric series. Okay, and we're going to be only talking about finite geometric series. This is an example of a finite geometric series. It's one that ends after a specific number of terms. So here we have 1, 2, 3, 4, 5. We have 5 terms and then it ends. If we instead had an infinite geometric series, which we'll talk about in a later video, I think 2 videos from now, this would keep going forever, right? That would just continue with the next term and so on. Okay, so this video is only finite geometric series. So the formula we need for the nth term, the sum of the first n terms, is Sn is equal to a 1 minus r to the n all over 1 minus r. So the Sn here represents the sum of the first n terms in a GS, so geometric series. A, of course, is the first term. N is the number of terms. So if you're summing up the first 3 terms, n will be 3. If you're summing the first 10 terms, n will be 10. And r is the common ratio. Okay. Perfect. So that's the formula. Now, one thing to note is that you might see different variations of that same formula. There's actually 2 variations, like I talked about earlier. One is this, a 1 minus r to the n over 1 minus r. And the other variation is this one. r to the n minus 1. So it's where the position of, no n here, just r minus 1. The position of the r and the 1 have been switched, right? In this one, we first have the 1 and then the r. In the second one, we have the r and then the 1. Okay, and these formulas are identical. There's no difference between the two. You will get exactly the same answer using both. The thing to pay attention to is that the order of the r and the 1 has to be the same on top and the bottom. So we either have to have r come first in both top and bottom, or r comes second in both top and bottom. So as long as it's the same both for the numerator and the denominator, then we are good. Okay, and if you're curious about why these two are the same, then the way you can show that these are the same is by simply multiplying the top by -1 and the bottom by -1. Of course, this doesn't change anything because we are multiplying both the top and bottom by the same number. That doesn't change the fraction. Okay, but if you distribute in the -1, you'll see that we end up with this formula. If you distribute and rearrange. Okay, so I'll leave that as something that you guys can try. Next, let's do an example on how to use this formula. So let's say we want to find the sum of 3 plus 6 plus 12 plus 24. So this is a geometric series. Why? Because the common ratio for all of the terms in order to go to the next term is 2. You have to multiply by 2. And it's finite because it ends. So in order to find the sum of the first 4 terms here, we can have more terms or less terms. I've just picked 4 terms here. In order to come up with the sum of the first 4 terms that we see here, we would write S4, sum of the first 4 terms, is equal to the first number, which is 3, right, or A, times 1 minus the common ratio of 2 to the power of n, where n is the number of terms we want to sum, so 4, all over 1 minus 2, right, the common ratio. So we get that S4 is equal to 3 times, so let's see, 2 to the 4 is 16, 1 minus 16 is 15, negative 15. All over 1 minus 2, negative 1. So this is going to be, this will give us S4 is equal to, the negatives cancel out, 3 times 15, that should be 30, 45. So we'll get this. Okay, so that's how we can use this formula. Of course, in the next video, we'll be going over a whole bunch of problems on this. So this is just a quick example to show you how the formula works, but we'll do a lot more examples in the next video. Okay, that's really it. So this formula is really all you need to know for geometric series. Okay. Yeah, that's essentially the end of the video. I will briefly go over where this formula comes from and show you guys the derivation at the end of this video. But I encourage all of you to stick around and watch how it's done, just because it's fairly simple. It's really easy once you see it once or twice. So I think it's worth spending time on. All right, so let's see where that formula comes from. I'll just write the formula here. So the formula we're trying to come up with is 1 minus r to the n all over 1 minus r. Okay, and here's how we can come up with that formula. Well, we know in a geometric series, we're trying to find the sum of the first n terms, right? So the sum of the first n terms will be a, first term, plus the second term, plus the third term, plus the fourth term. Sorry, 1, 2, 3, yeah, should have been 3. There we go. Fourth term plus all the way up to the AR to the n minus 1 term. Okay, so this is the sum we are trying to find, the sum of the first n terms of a geometric series. Now, why are we going up to r to the n minus 1 instead of going up to r to the n? Well, that's because including the a here, this is going to give us n terms. Okay, so if we count all the terms up, from AR to the n minus 1, that's n minus 1 terms. And then we have the A, so that's going to be n terms altogether. Okay, so that's what we have. Now, here is what I'm going to do next. I'm going to multiply. I'm going to write down the same thing. So Sn is equal to, and I think I want to rewrite it like this. So a plus ar squared plus ar cubed plus dot 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 all the way up to ar to the n minus 1. We're going to take this whole thing and multiply both sides by r, our common ratio. Okay, and there's no problem with this, right? We can multiply both sides by a number, as long as, that number isn't 0 and we do the multiplication on both sides. So that's going to give us RSN here. And on the right side, I'm going to distribute these R's in. So what is R times A? Well, that's AR. What is R times AR squared? Oh, this should have been AR and then AR squared and then AR cubed. Sorry, I missed the term there. There we go. Okay, so R times A is AR. R times AR is AR squared. Then we have AR cubed, and so on. So let's see what we get when we multiply R by AR to the n minus 1. Well, that's going to give us, so we're going to get all of these terms all the way until this. R times R to the n minus 1 will be R to the n, right? Using the power rules, if we multiply R to the n minus 1 by R, that's going to be, so this is R to the 1, that's going to be R to the n minus 1 plus 1, which is just R to the n. Okay, so this is what we're going to get. All right, so I'm going to replace, right? We distributed it in. That's what we get. I'm going to replace what we have here by AR plus AR squared plus AR cubed plus AR to the 4 plus dot 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 all the way up to AR to the n. Okay, so all we did is we wrote down the geometric sequence. We said, okay, let the sum be equal to Sn. We multiplied that on both sides here. Okay, and now we're going to do something kind of clever. We're going to subtract everything on top. So we're going to take everything on top and subtract everything on the bottom from that. So we'll take Sn. Maybe let me draw a subtraction here. So subtract. We're going to take Sn and subtract Rsn. So we'll get Sn minus Rsn. That's equal to, what is A minus, and we don't have any A terms here, right? There's no term that is similar to A. The closest thing we have AR. So A minus 0 is just A. AR minus AR is 0. AR squared minus AR squared is 0. AR cubed minus AR cubed is 0. All of these terms will cancel out. And what term do we have just before AR to the n? We would have AR to the n minus 1, right? The term right before R to the n is R to the n minus 1. So that's going to cancel out with that. And we'll end up with negative AR to the n. Okay, so I just want to maybe highlight what happened one more time. When we do this subtraction that I was talking about, the only two terms that survive is A on top and AR to the n on the bottom. So we're going to end up with a positive A, and we were subtracting the bottom series, so we end up with negative AR to the n. Okay, so the reason this is negative is because we're subtracting the bottom line here. Okay, so great, we have this equation. Now our goal was to solve for the sum Sn. So here's what we can do. I'll take this, I'll factor out Sn, and that'll give me 1 minus r, which is equal to A minus AR to the n. I'll factor out A over here, so that'll give us Sn times 1 minus r is equal to A 1 minus r to the n. and I'll divide both sides by 1 minus r. Okay, that'll cause this to go away, and we get that Sn is equal to a times 1 minus r to the n all over 1 minus r. Okay, and this is exactly the same formula that we started out this video with. Okay, so we solved for Sn. Okay, we came up with a formula, and what was Sn? Well, Sn was the sum. We defined this geometric sum to be equal to Sn, and we solved for the formula Sn, right? And we got this. Okay, so that's the derivation of that formula. Okay, but for doing problems, the only thing that you guys will need to memorize or know is this formula right here. Okay, I hope you guys found that helpful. In the next video, like I said earlier, we'll be going over a whole bunch of problems that I've prepared. And if you have any questions, please feel free to leave it in the comment section. All right, see you guys in the next video.